Hey everybody, it's Miss Berry. In this video, we're going to go over section 8.3, which is called Describing and Analyzing Data. So let's go ahead and get started. Okay, so again, this section is called Describing and Analyzing Data. In this section, we're going to talk about how to calculate some various quantities from a sample. If you remember, these are called sample statistics. So we'll look at three measures of central tendency. These are called the mean, the median, and the mode. What central tendency means is this is like the most typical value in a data set. It is these are the three best ways to describe the average or the middle, the center of a data set. So the average, central tendency means like the average or the center of a data set. So we have what's called the arithmetic mean, the median, and the mode. The mean is just, again, your arithmetic average. So this is where you add up all the data values. Oops, sorry. Not sure what I did there. Let's see if I can get that to go away. Okay. So you add up your data values and then divide by the total number of data values. In the sample. I'm going to come back and talk about the symbols for these. The median is the middle of the data set. So it's the middle value in a data set. And very, very important, in order for you to find the median, the data values must be in order from smallest to biggest. All right, and then the last measure of central tendency is called the mode. And the mode is the value in the data set that occurs most frequently. So we'll just say most frequently occurring data value. All right. There are several types of modes that you could have, or several different ways that you could describe the mode in a data set. If you have just one mode or just one number that occurs most frequently, that would be called unimodal. If you have two numbers that occur most frequently and they occur the same amount of times, that would be called bimodal. And then if more than two data values occur equally often and more often than any other data value, then we call that multimodal. All right, so let me go back and tell you the symbol up here. For mean, the mean has two different symbols. If you're talking about a population, then we use the Greek letter mu to represent the mean. It kind of looks like a cursive M. It kind of looks like a U, but that's the Greek letter mu, M-U, mu. And if you're talking about a sample mean, then we refer to that as X bar. So it's an X with a line over it. And this again is called X bar. X bar. So that's the sample mean. Let me see if I can write that a little bit neater. All right, so that's X bar. I think that's a little better. All right, the median does not have a symbol, and the mode does not have a symbol, so you don't have to worry about knowing the symbols for those. All right, let's look at the next three measures that we're going to look at. We're looking at, the next two measures we're looking at are the measures of dispersion. This is going to tell you how spread out a data set is. All right, so again, this tells you how spread out a data set is. So it describes the spread of a data set. This tells you how close together the numbers are in your data set. So the larger your measure of dispersion, the more spread out your data values are. The range is super easy to calculate. The range is just equal to the largest data value minus the smallest data value. It does not have a symbol, so if you have to find the range, you have to write out the word range. And then the standard deviation does have a symbol. Again, we have two different symbols for standard deviation. I'm going to write them in purple over here, just like I did for the mean. If you're referring to the population standard deviation, then we use the symbol, the Greek letter sigma. All right, so that is the Greek letter sigma. That's a lowercase sigma. And then if you're talking about the sample standard deviation, then you just use the letter S, lowercase s. So you may have heard of the word range before. The standard deviation may be new for you. So the standard deviation is a measure of how we might expect a member of the data set to differ from the mean. So this is how far away from the mean that you're expecting one of your data values to be. The formula for the standard deviation is pretty complicated. I'm just going to write the formula for the sample standard deviation. If you would like to see the formula for the population standard deviation, it's on page 409 of your textbook. But this is the formula for the sample standard deviation. So it's the square root of, and then there's a fraction inside. We got this symbol we haven't talked about before. So it's the Greek letter. Sorry, I just blanked. The Greek letter sigma. This is a capital sigma, or the sum. When you see a capital sigma in math, that refers to the sum. S-U-M. Sum. So it's the sum of x sub I minus x bar squared all over n minus 1. Now, I'm going to tell you what all these things mean. So x sub I is the ith data value. X bar, of course, is our sample mean. And n is your, what we call the sample size. That's how many data values you have in your data set. All right, so this looks really complicated. I'm going to show you how we can make a little table to calculate the standard deviation. It makes it much easier than, thinking about it in terms of this formula. So the standard deviation, again, is a measure of how you might expect a member of the data set to differ from the mean. So how far away from the mean are we expecting one of our standard data values to be, or one of our average data values to be? All right, so let's look at some examples. All right, so the first one says, find the mean of the following data set. Assume the data set is a sample. Round your answer to the nearest hundredth if necessary. So that means 2 decimal places. All right, so if we're finding the mean, again, this is a sample, so we're looking for X bar, the sample mean. So all you need to do is add up all of your data values and then divide by the number of data values. Let's count up how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we would say our sample size is 11. All right, so that's the number of data values we're working with. All right, so we're going to add up all of our numbers. 49 plus 50 plus 50 plus 51 plus 45 plus another 45 plus 48 plus 44 plus 38 plus 55 plus 42, all over 11. All right, so you don't have to write this out like what you're plugging in the calculator. You could just go straight to the calculator and plug it in. I'm just writing it out just so you can see what I'm doing. All right, so let me scoot this over a little bit. All right. So let's go ahead and add this up. I'm going to hit my fraction button. If you don't have the little fraction button, make sure you put the numerator in parentheses. So make sure you start off with a parentheses and start typing your numerator. Right, but I have that little fraction button, so I'm going to put it, I'm going to use it. Right, but again, if you don't have the fraction button, make sure you put the entire numerator in parentheses. All right, so 49 plus 50 plus 50. 50 again, and then 51, 45 twice. Oops, 45. Trying to make it where you can see it better. All right, then 48, 44, 38, 55, and 42. All right, and then we're dividing by 11. All right, and there's our mean, our sample mean, or our arithmetic average is 47. So X bar is 47. Great job. All right, so let's look at our next example. All right, it says a researcher randomly purchases several different kits of a popular building toy. The following table shows the number of pieces in each kit in the sample. Find the median of the data. All right, so this is building toy pieces. So this is some kind of toy, and this is how many pieces. Maybe we're talking about like Legos. This is how many Legos are in each of the sets. All right, so we have 158, 263, 348, 102, 263, 168, and so on. All right, so they want us to find the median of the data set. That means that we need to list these in order from smallest to biggest. All right, so let's see, definitely the smallest is 43. You can kind of cross them off as you use them. 43 occurs twice. All right, see, our next biggest number is 102. And then 107. All right, let's see, the next biggest number would be 158. Then 168. Okay. Let's see, our next biggest number is 206. 263 occurs twice, so write that one twice. And then 294. I'm going to move these down here so I can fit them all on one line. Oh, man. Right, let's see if I can do this. Right, there we go. Okay, put back that 43 at the beginning. All right. And then 348 twice. Sorry about that interruption. while I had to move that down there. All right, cool. Now that you've got them written in order from smallest to biggest, this is how I like to find the median. I will start on one end and I cross off a data set, or excuse me, cross off a data value, go to the other end, cross off a data value, then cross off the next two, and the next two, the next two, all the way until you get to the middle. All right, now here's our middle. Sometimes you'll just end up with one in the middle, and then sometimes you'll end up in a situation like this where you have two in the middle. If you have one in the middle, that's the median. If you have two in the middle, you have to find the average of those two data values. So you go up here and you'll say, okay, well, I know that the median is going to be the average of those two data values. So it's 168 plus 206 divided by 2. So 168 plus 206 divided by 2, and there's our median, 187. So 187. All right, so again, sometimes you'll end up with two data values in the middle, in which case you just find the average of those two. If you end up with just one data value in the middle, super easy, that's just the median. Okay, let's look at another example. This one says, identify whether the following data set is unimodal, bimodal, multimodal, or has no mode. It's totally possible that a data set could have no mode. That doesn't mean you've done anything wrong if you get no mode. That just means there's no value that occurs more frequently than other values. It says, assume the data set is a sample and find the modes if they exist. All right, so let's see. 50 occurs twice, so that's a possible mode. 45 occurs twice. Do you see any other data values that get repeated? 49 doesn't get repeated, 51 doesn't, 48 doesn't, 44 doesn't, 38 doesn't, 55 doesn't get repeated, and then also 42 doesn't get repeated. All right, so we have two data values that get repeated twice. That means we have two modes. So that means this is a bimodal data set, has two modes. Two numbers that occur more than the other values, and they occur the exact same number of times. They both occur twice. And then our modes are 50 and 45. So this is a bimodal data set. It's got two modes, and those two modes are 45 and 50. It's a little arrow right there. All right, so we found the mean, the median, and the mode. Now we are going to look at the range. Again, the range, super easy to find. It says find the range of the following data set. Assume the data set is a sample. So if you remember, the range is just the largest data value minus the smallest data value. All right, so what's our largest data value in this data set? Let's see, 55. And then our smallest one is 38. All right, so range is 55 minus 38. Let's see what that is. 55 minus 38 is 17. So that's the range. All right, and then now we're going to look at the standard deviation. Again, the standard deviation is a measure of how far we might expect a member of the data set to be from the mean, or how much we might expect that member of the data set to differ from the mean. This is the formula for the for the sample standard deviation. It's the square root of the sum of x sub I minus x bar squared. I feel like I might have left the squared part out when I wrote the definition. Nope, I got it in there. All right, so x sub I minus x bar squared. Then you sum up all those little differences. Those are called, this is called the dispersion here. So that's how far away from the mean each data value is. And then you divide by the sample size minus 1. All right, so I told you guys there's a little table that you can make that makes calculating the standard deviation a whole lot easier. So I'm going to draw that little table for you. All right, so let's make a little table. See if I can make one on here. Oh, use my mouse. Okay, I think this size box looks fine. All right, so we're going to make our first row, and then we will have the number of rows that you're going to have depends on how many data values you have. We'll just do a few here. And you're going to have 3 columns. So 1, 2, and 3. Let's see. The last column needs to be the biggest. So we'll do it like that. I think I want to move it over a little. Like that. Okay, perfect. All right, so this isn't perfect. You can see I just kind of threw this together. It's okay if it's not perfect. This first row is going to be our, just like tell us what we need to write down. The first one is your data value. This is represented by x sub I. And then we're going to do x sub I minus x bar in the second column. And then the last column, we're going to take whatever you get in the second column and then square it. Okay, so this table really, really helps you break down the formula for finding the standard deviation. So you can see we're taking we're listing out each data value, that's the x sub i's. Then we're taking and subtracting x sub I minus the mean, that's in here. And then we're squaring those. So we're breaking it down step by step. All right, and then in here, again, the number of rows that you have is going to depend on how many data values you have. All right, so let's copy this over for when we go to the next page. It says, find the standard deviation of the following data set. Assume the data set is a sample. Round your answer to the nearest hundredth if necessary. Dang, didn't copy over. Let me try again. There we go. All right, so we have, I think we counted this data set earlier and there were 11. Let's just make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so that means we're going to need 11 rows in our table. So we're going to need to make this way bigger. All right, so 1, 2, 3, 4. Go ahead and start drawing your table. 5, 6, 'Might just scoot some of these up and make them smaller to fit them all in. All right, so make sure you have 11 rows for our 11 data values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Right, so just going to count those again just to make sure. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. All right, so I'm going to go ahead and start writing in the data values. If you haven't got your table written yet, pause the video. All right, so here's my data values. It doesn't matter what order you write them in. Just going to go in the order they're written in. 49, 50, 50 again, 51, 45 twice, 48, 44, 38, 55, and 42. Okay. All right, now for this next column, you need to know the mean. We just happened to find the mean already. We found the mean in number 1, that was 47. But if you don't already know the mean at this point, you need to go off to the side, add all of your data values up, divide by the number of data values or your sample size to find the mean. But again, we found it earlier and we found that X bar was 47. All right, so this is you're gonna want to write small in here. 49 minus 47. Yeah, so our data value minus the mean. So data value was 49, mean was 47. So 49 minus 47, go ahead and simplify that. That's 2. Right now, our next data value is 50. 50 minus the mean. So 50 minus 47 is 3. Continue this pattern, data value minus mean. So 50 again minus the mean is 3. Next, we have 51 minus the mean is 4. 45 minus the mean. 45 minus 47 is negative 2. 45 again, so 45 minus 47 is again negative 2. 48 minus 47 is 1. 44 minus 47 is negative 3. 38 minus 47, let's see, is that 9? Negative 9? It is. You want to be careful here because if you mess up on this step, it's going to mess up your entire answer. All right, so 55 minus the mean. See, that would be 5. Nope, that's not right. 55 minus 47 would be 8. My bad. All right, and then 42 minus the mean is negative 5. All right, we've got the second column filled in. We're getting close to being done. All right, now you're going to fill in your third column. You're not done after you fill in the third column, but we're getting there. All right, so you're just going to take whatever value you got in this column and square it. So 2 squared is 4. 3 squared. Try that again. 3 squared is 9. There's 3 again. 3 squared is 9. Whoops. Okay. 4 squared is 16. Negative 2 squared is 4. Make sure you put that anytime you're squaring or raising a negative number to a power, you always have to put it in parentheses in your calculator. All right, so anytime you're raising a negative number to a power, you have to put it in parentheses in your calculator. All right, so negative 2 squared, that's negative 2 times negative 2, which is positive 4. 1 squared is 1. Negative 3 squared is 9. Negative 9 squared is 81, the big one. 8 squared is 64. And then negative 5 squared is 25. Okay. Now, we've got our table filled in. Now we just need to add up, because that says the sum. It's the square root of the sum of the deviations squared. So we've got the deviations squared here. These again are called the deviations. It's how far each data value deviates from the mean. All right, so we're going to take, let me write down our formula. S is the square root of the sum of the deviations squared all over n minus 1. All right, so the next step after you fill in your table is to add up all of the deviations squared. All right, so the total, we'll add them up and write it down there. So again, this is going to be our numerator. It's the sum of the deviations squared. So go ahead and add up all those values. Let's see if I can move this over. Okay. All right, so adding up my squared deviations, we have 4 plus 9 twice, 16, 4 twice. Be careful adding these up. Plus 1, plus 9, plus 81, plus 64, plus 25. All right, so there's our numerator, 226. All right, so we have S equals the square root of the sum of the squared deviations was 226. You can write that down here as well. So that's your numerator. Now our sample size is what is represented by n. So n again is the sample size. You count up the number of data values. There's again 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going to be 11 minus 1 in the denominator, which is 10. So that's the square root of 226 over 10. Now all we have to do is type this in our calculator. Oops, clear that out. So square root, you can see my square root is right there. Or sorry, it's actually right there by the 7. All right, so it's second x squared brings up a square root. So it's the square root of a little fraction, 226 over 10. There you go. Round to the nearest hundredth. So that's two decimal places. So it's 4.75. That's it. All right. Now, I know that that's hard. It's not easy. I took this problem off of the homework. I would not put this many data values in the data set whenever I ask you to calculate the standard deviation on the test. So on the test, I'll probably put like 5 data values. This one has 11 data values, so it was a lot more to calculate. The smaller your data set, the easier the standard deviation is to calculate because you don't have to do all of this work that we did in the table here. Again, I wanted to do this one in particular because this, again, is off the homework, and this is what you should expect to see on the homework. But on the test, the sample set or the sample size will be much smaller. All right, so that is it for this video. If you have any questions, please let me know. Otherwise, I'll see you guys soon. Have a good day.